Welcome to day 2 of TechCon. My name is Jesse Geip. I'm the Venture Portfolio Director for the Defense Innovation Unit. We've got a great panel here today talking about autonomous horizons, the current state of sea, land, and air. So we've got folks from all three different domains here to talk a little bit about where we see these different industries moving, initially with a focus on the Department of Defense, but also talking more broadly across not just defense, but also commercial sector. So just kind of set the stage a little bit about DIU, so Defense Innovation Unit. We are within the Department of Defense, and as an organization, started in 2016, we were really established with the framework that there is incredible technology being developed in the commercial sector that has national security implications, but is not well being integrated in the department. And if we really want to leverage America's economic advantages, then we need to be working more effectively with dual-use technology within a department. There's massive amounts of R&D taking place in the commercial sector that's actually outpacing the federal government. You look back historically, post-World War II era, even kind of close to the end of the Cold War, most of the R&D in the United States was actually driven out of the federal government and the federal lab infrastructure, and that has significantly changed through time. And so if the United States wants to remain a technology superior military, then we have to rely on the significant investment that's taking place in great companies outside of just kind of core defense activity. And so that's why DIU was established in 2016 to develop new contract methods, new approaches to identify those capabilities and then bring them into the government and work on national security problems, and ultimately to do so on a timeline that's relevant both to those companies who are likely venture-backed and have aggressive timelines for growth. So, we can't be trying to have winners picked 20, 30 years down the road. Like, we need to be bringing these companies in and helping them mature alongside us as a government user on a timetable that's relevant for the pressure they're under with their investment cycles. And so that's why DIU was created. We've grown significantly over that time from about a $150 million organization to a $1 billion organization. And we continue to grow and our mission continues to change. So really excited to talk to all three of these folks today. With that, I just want to open with a couple of things that probably a lot of the folks in the room are tracking, but a couple of kind of underlying headlines that are sort of like driving what's happening in the autonomous space. But earlier this year, obviously we had NVIDIA launch Cosmos, a new hardware capability to really drive robotic platforms, right? So we have the front runner in all the chip development and AI in the world, leaning into ground-based robotic systems with a new technology development. China last year announced that they launched their first 50,000-ton aircraft carrier for drones. China placed an order for nearly 1 million lightweight kamikaze drones. DJI, which owns 2/3 of the commercial drone market, and this is going to tie into the counter-UAS side, recently just announced that they're no longer geofencing the DJIs from flying in airports around the United States, which is a nice turn for them. And in 2023, the DoD launched a program called Replicator, which was really focused at scaling thousands of unmanned systems in air, land, and sea, with a focus on supporting the Indo-Pacific region. And so that program has already worked with dozens of different companies and has selected a variety of capabilities, some of which we discussed publicly, others of which we will not. And now we've also announced Replicator 2 within the department, which is focused on the counter-UAS side. And certainly as we see the robotic side grow on the application, there's also going to be a counter side. So counter-UAS, counter-ground, counter-sea. So both of those two kind of pillars are growing dramatically on the defense side. And then just as a last one, ending with a fun tweet from Elon. So Elon tweeted just earlier this year, meanwhile, some idiots are still building manned fighter jets like the F-35. So depending on how much weight you think Doge and folks like Elon have in the new administration, there's a lot happening within the Department of Defense context for investment in unmanned platforms, and there's potentially a lot changing in our market, and there's certainly things happening outside of our market that we're looking to leverage. So as that is kind of like table stakes, I'm going to jump right into it and open up with John. And as we kind of go down, if you want to do quick intros, actually let's do the intros first, and then we'll do the questions. So Amir, to you first.
Okay. First off, thank you for having us here and having all of us on the panel. This is particularly special for me because I went to San Diego State back in 2011. I graduated with international security and conflict resolution. So a lot of my life has been put toward, trying to protect our national interests. And the last 15 years has been dedicated to developing autonomous technologies for defense and public safety. I started a drone company down here. It was way too early. That's actually where I met Dan in. I started a drone company in LA out of Caltech, and then now I'm running an autonomous ground vehicle company called Airway, where we empower both commercial and military airfields with autonomous ground systems, AI-enabled systems to make their operations and maintenance far more efficient. We're closing around right now. I'm pretty close to it, so if there's any VCs, I'm going to put a plug in that we're looking for one last check. We have partnered with a defense company called Moog, and they're focused on digitizing airfields, which is essentially what Airway wants to do. And so we've been doing that as part of Airway's efforts and doing demonstrations across different naval air bases and Air Force air bases. But the bigger challenge that we're trying to address is essentially what you were talking about, Jesse, and that is, how do we digitize, modernize, and empower the new installations and the airfields that we're going to revive across the world in order to deter threats from places like China, Iran, Russia, et cetera. So it kind of ties together all the stuff I've been trying to do. Thank you.
John Falcone. So I started my professional career as an investment banker in financial technology right after the 08 financial crisis. So it was kind of like in the disruption space with large financial institutions at the time. Made a pivot though, went to officer candidate school, joined the Navy, did my first deployment in 2013 to the Middle East in support of counter-terror operations, primarily operating Scan Eagle, which is probably one of like the first maybe like ship-based UAV. Did my second deployment 2016, 2017 to the Western Pacific, where I was the anti-submarine warfare officer, responsible for deploying and experimenting with new acoustic and underwater sensors. And then my last tour was deployed again to the Western Pacific as the chief engineer on board a minimally manned, highly automated engineering plant, and then tactically responsible for employing the Fire Scout UAV and USVs in support of mine warfare and surface warfare. In addition to that, I served at the United Nations headquarters in the Department of Peacekeeping Operations, doing technology analysis, integration of technology into election integrity, and also disaster relief. And now I sit at Defense Innovation Unit as the surface warfare lead in the Maritime portfolio.
You'll probably realize I'm not Dan Meiji. So I'm Dan Meiji's co-founder, Ian Mucius. So I'm the CTO at Firestorm. We're a US company kind of based in a cauldron of additive manufacturing meets aerospace. And so my background just happens to be those two things. So aerospace engineer who spent a lot of time in software startups and then realized I like to do a little bit more hands-on work where you're producing real products. And so got into bleeding edge additive for about the last 10 years. Dan and I got connected about 3 years ago now, and he had a simple question. Could I build him a $10,000 cruise missile in the lead up to the war in Ukraine? And I said, that's maybe interesting. Well, let's think about what else we could do. And we really look at it now of like, obviously quad rotors are massive in Ukraine and they'll continue to be massive around the world. They're easy to fly, all of these types of things. But really what the US and our allies need is a modular platform that can adapt at the speed of warfare. And so what we see today is a cat and mouse game that's technologically empowered, the likes of which the world has never seen. And it will continue to grow and be more difficult to keep up with the enemy. So our platforms have to evolve as fast as that evolves. So yeah, thanks for letting me be here.
Awesome. Well, I'm Grant Jordan. I'm the CEO and co-founder of SkySafe. We're actually based here in San Diego. We're a for the purposes of this panel, it's the most counter drone company. We started out focusing on the military side, but as I think we'll dive into, there's a lot of other commercial applications when thinking about how do you track and manage and coordinate the airspace, whether that's with unmanned aviation teamed with manned aviation and all of those things. In a former life, I was an Air Force officer working in AFRL in the Air Force Research Lab. So I worked on a lot of stuff back in the day around small UAVs, how to deploy them tactically, sensor systems, and it's almost quaint to think about now, but back when I was in AFRL, it was kind of the early era of the DoD starting to think about like, oh, what are these small drones? Are we gonna have to start worrying about that as a non-nation state adversaries, bringing them to the battlefield. And yeah, I think that's proven out pretty conclusively now. There's no question. And so we think a lot about, how do we deploy sensor networks to track drone activity, to deconflict airspace, and to really like understand who's doing what where, right? There's a big problem with kind of identify friend or foe, especially when you see in the current world of drones, it's kind of everyone's sort of flying the same drones, whether you're a bad guy or a good guy, commercial operator or government, there's a lot of overlap in what drones they are. So you can't just kind of look up in the sky and see and identify whether that's a good drone or a bad drone. So, happy to dive in on all that stuff.
All right, thanks, guys. And so before we go deeper, just quick, and John, maybe this doesn't apply to you as part of the government, but quick show of hands. Yeah, with this the next one.
Going to give I do not represent the views of the Department of Defense or the U.S. government or any current or future
That is also
employers.
true. I represent myself here today. Yeah. No, but before we go deeper, just by show of hands, today, what's more important to your business as a market, the defense federal market or commercial markets? So if it's defense, commercial, yeah, it's down the road. So
I'm going to have my hand right here in the middle.
You're right in the middle, midway.
It's a split.
Okay, and then the second part of that question is that going to change in a different direction in the next 3 to 5 years? And if it's going to decrease defense or increase defense, where do you answer that?
I could start us off. I think especially when we're thinking about autonomy, I can obviously speak more to the drone space, to the kind of air-based autonomy, but I think depending on the space you're in on the startup side, I think usually you think about dual use as starting on the commercial side and then being adopted by the government. In autonomy and AI in a lot of areas, it kind of often goes the opposite direction, right? In drones, I think we started out on the side of seeing drones on the battlefield, seeing, especially because low cost as far as drones are concerned starts out in what the government considers low cost and then evolves into what everyday people think of as low cost. Back when I was in AFRL, I think our idea of low cost for a drone was like $50,000. That was like, whoa, it's incredibly cheap. There's so many of them. And now for probably about $500, any kid can buy what is greater capability than what we had at the time. So, for us at SkySafe, we started out focusing almost entirely on the DoD and the government side. Our first customers were Naval Special Warfare, and our first contract was through DIU, at that time DIUX. But as you see that kind of adoption curve go on, you see drones being used for all types of different commercial operations. You see, hobbyist adoption massively. And so it becomes that a lot of the thought process and problems that the government starts out with then go into the commercial space. The same problems that you think about with a like DoD facility or airbase, those are the same worries that any commercial airport operator has about drones in the airspace, threats to the area. And now, that's evolved to like critical infrastructure providers, power companies, oil and gas. And one of the things that we think about a lot, when you start out on the military side, you're mostly thinking about kind of threats. You're thinking, adversaries, bringing these to the battlefield. But as that evolves, it's also about how do you utilize them for your own operations. So when we talk about the commercial side, power companies, oil and gas, they all want to be using drones for their commercial operations, doing inspection and maintenance and all of those types of things. And one of the first problems they run into when they start utilizing these for their own work is that identify friend or foe problem. You realize that, if I'm running a natural gas plant and I see a drone flying in, I have kind of a moment there where, I see some random off-the-shelf drone. Is that the drone that we're using on our team to inspect the facility that's like scheduled to be here? Or is that some Yahoo that I need to be worried about, that I need to go start flipping switches and shutting down things and evacuating? And so that, I think all sorts of customers, both government and commercial side, realize pretty quickly that this kind of problem in airspace management, in understanding, and in really understanding the data around it becomes super important. So a little bit of a long-winded way to say that commercial side is really increasing. And I think, and I suspect it's not just the case in drones, it's also the case in all levels of autonomy for all of these companies.
Yeah, we started obviously answering kind of the question around how do we counter the situation like Ukraine is going through with an aggressive enemy at your border. and that will trickle into the commercial space. But really, what I think will lead us into the commercial space more is our manufacturing methods. So we're partnered with an OEM as our 3D printing technology, our print process. We're customizing, kind of bending that process to our whim. And the future of a tradable UAS, low-cost UAS, like we use, obviously one-way attack type stuff, maybe doesn't have a place in the commercial space, thankfully, but our manufacturing method does. And so we'll get drug in that direction with our manufacturing method. We'll end up using that manufacturing method for other things. If you can print nylon, you can make a lot of different plastic stuff. You don't just have to make, aerostructures like we do day to day. So our expeditionary manufacturing technology is called XL. We will use XL obviously to print our aerostructures. In the future, though, we're already partnering with folks on other use cases that we can deploy in the commercial sector, and that can be everything from PPE. We printed nasopharyngeal swabs during COVID with this technology. I mean, pretty much anything that you can, again, make out of polymer. So that'll drag us there. The UAS space probably will too, but probably mostly focused on defense, homeland security, those types of applications, less so on the drones themselves being used commercially, at least in the next 3 to 5.
Okay, I did want to add something to it.
You're the commercial guy. You go.
Well, the other angle that I see through this too is from the UAV and the UGV angle. And no matter what, when we're going after whether it's commercial or it's defense, we're still dealing with regulators, and even on the UGV side. And it's surprising now that we're working with a lot of commercial airports to see that a lot more progress has been made with UAVs and in the introduction and the adoption of UAVs in an airfield than with UGVs. Fortunately, we're working with, and this is a recommendation I would give to any company that's, looking to get into both commercial and defense. You work with the regulators, and specifically, we're working with the Part 139 certification teams and the rulemaking and advisory circular, the guys who push out the advisory circulars around how airports should adopt these types of new technologies in a safe manner, and working then with the airports in order to, you have to have it's really fundamentally a product development process. You got to have a tight iterative process with your customers, introduce the technology, get the feedback, improve it, but at the same time do so in a very safe manner. So whether we do it on defense or we do it on commercial, we still have to deal with federal regulators to make progress. But from one last thing, sorry. From, call it a venture perspective, I get the question all the time, do you think it's defense that's going to kick off first, or do you think it's the commercial market that's going to get you the traction? And we have to pursue both at the same time because it's new technology, it's novel, and trying to get both the commercial sector and the defense sector already, each of them has its own challenges from building the market perspective, but then introducing a new tech, you really have to go through the grind to do it, and you don't know which one's going to kick off, right? Until one of them does, and you might get one customer from the commercial side that you have to, leverage and work with in order to grow, and then a defense, customer might be interested too. So,
and John, if I'll ask you the first question here, so right. Come to you here. So, and when you look at, a little bit different maybe in the commercial market, but on the defense side, across those three domains, I think it's fair to say air is probably further along in terms of the number of systems and the deployment of systems that are integrated into the U.S. military, followed by sea and subsea, with maybe ground as sort of the lagging of the three in terms of the volume of robotic systems that are deployed. And there's maybe a variety of different reasons for that to be the case. But John, I'll start with you. Can you talk about where you see the sea and subsea world moving for the Navy on autonomy, and like what is finally changing adoption from a DIU perspective in those categories? And are there some kind of really core new capabilities that have come on the market that have changed maybe some slower adoption than maybe folks when DIU might like, but that we're still seeing some bigger movement across the Navy for larger system adoption?
Yeah, absolutely. So. And I mean, I would argue that the maritime space might be actually, from a technical side, the greatest laggard. Maybe like defense acquisition, right? The ground vehicle side is the laggard. But from a tech development standpoint, the surface vessels and underwater vessels are probably the greatest laggard. And the simple answer to that is the tech wasn't there. And the tech is finally catching up. So like for me, frameworks are helpful. So it's like, what differentiates the maritime domain from some of these others? And so kind of the broad buckets I would use is the environment, communications ability, endurance, and cost, right? And so from the environment side, you're operating, and it almost sounds silly to somebody that hasn't like lived on the water for their lives, but like the salt air and the salt water environment is deadly, right, for these systems. Try to even, let's just say like a simple data acquisition unit, or like just a data server to acquire information about what's going on this vessel, like bolt that into a hull and see what happens with like a 2-foot waves for about 30 minutes, right? The thing is going to be ripped out of the hull, right? And that vessel's probably going to be at the bottom of the ocean, right? And so it's like all of these types of things, like how do we ruggedize data, like server racks, right, for here? How do we support cooling for that data, for those servers, for the other systems that are on board? And so, you know, over the last decade, you saw a lot of kind of focus on the LUSV program, and it's just a very challenging problem. But
Just for those who may not know the acronym.
sorry, large unmanned surface vessel, and the things that are kind of lagging in that, right, were things like the computer vision, the ability to operate in the regulatory environment, rules of the road is kind of like the set of standards in which these vessels operate. So just like that salt, air, and water environment, right? Straight up physical environment. Communications, depending on what the height of eye is, or in other words, like how far off of the water line your antennas might be, that is going to physically limit how far you can communicate with somebody. And so whether that communication is to some type of command and control node, some type of remote control, all that's going to be limited by the maritime environment. And again, add in the sea state, add in that vessel just rocking. If you're talking about underwater applications, now we're not talking about radio frequencies. We're talking about acoustics, right? Acoustic and sonar, right? So again, another technical challenge. Endurance, no knock on UAVs, but right, like when we think about the Ukraine battlefield, I mean, when you compare it to the Pacific, we're talking about units operating in kind of very close proximity to each other. And so like, yeah, it's great when you can get 10 hours, right? I'm operating in the Pacific, I need 30 days. So how am I keeping that vessel operating for 30 days? How am I making sure I maintain those communications, right? So we were getting back. And then, kind of for all those reasons above, the cost side just gets amplified over and over and over again. So each of those things, I don't know, maybe we'll get to the point where we can 3D print some of these holes, but like if we use plastic and you're deploying it in any type of weather, right, that's going to be destructive to the equipment on board, things like that. So, it's tough to manufacture these at a low cost. So that's why I would say USVs, UUVs kind of lagged in that space. But so what are the kind of like the good fronts going on now? The control systems, the things that control the operation of these vessels are significantly better. The ability to finally control whatever engineering functions are on board these vessels are far superior than they have been, right? That is like a recent 2 to 3 year type thing. The computer vision and recognition of other vessels out on the water is significantly different. The ability to have compute power on board in small spaces, because again, think, right, space is limited, right, on board these type of vessels, whether it be surface vessels or underwater vessels. So getting compute power down to a smaller size that it could operate all these autonomy functions going on. So kind of, long-winded way, but like all these kind of like little progressions that happened in all these other domains could finally be adopted and kind of hacked together in order to support the maritime domain.
Yeah, thanks, John. It's going to be interesting to see how the next few years play out for the Navy, but certainly a lot more push, it seems like, in these last 5 years, right, to see these systems go past sort of DARPA prototype into scaled capability that's operationally relevant and deployed.
Yeah, and that just said, publicly released, DARPA just successfully refueled an unmanned surface vessel at sea. So they were able to bring a ship alongside. They threw autonomously threw a planer in there. So just think of it as a small vessel that had a line attached to it. The manned oiler came up, picked up that rope out of the water, brought it on board, hooked it up to their tension winch, and then the two vessels navigated alongside each other, and they were able to refuel at sea. That was no more, I think it was less than a month ago. So we're talking about, like, again, the computer vision, the autonomy, the engineering control, the tactics, right? Like, in order to do that, we have seen just incredible leaps in the very recent time frame.
All right. Yeah, thanks, Sean. So Ian, this is to you. When you look at the adoption in unmanned systems, right, and you kind of have, for those of us who know the different like group categories for unmanned, right, you can kind of go from your very large global hawk systems, right, that are flying at high altitude and, kind of exquisite systems down to the, quadcopter, very expendable, low cost. Where do you see the adoption changing the most in the market right now? And do you really feel like there is the rhetoric kind of matching, what is happening on the acquisition side, and kind of where do you see the defense market continuing to move in autonomy? And you kind of already hinted at, what's happening in Ukraine and maybe how much that's driving change for the U.S.
Yeah, there's a lot of hyperbole going on. But essentially, until compute gets to a point where this thing isn't as good as it is, we're still ahead of the robots for a while, luckily. But no, I do think there's some truth to it, right? I mean, we do have to be building systems where we're not worried about losing the squishy body that's sitting in the seat of that system. That's, for all the shade that gets thrown at America, we still do really care about things like collateral damage. We care about, we're not sending our people out onto the front to be cannon fodder. So we do a really good job of that as far as other countries on the world stage. But I do think there is going to be this adoption of all through the groups, as you say, group 5 down to group 1. Group 1, you're talking like sort of up to 22 pounds. Then group 2 kind of goes up there from there. And I do think there will end up being more capabilities at those lower group classes that are able to kind of compete with what used to be Predators, Reapers, Global Hawks type of capabilities for a much lower cost. And so you'll see some of these militaries around the world start to adopt those in place of these larger, more expensive platforms. And there'll be some kicking and screaming along with that, right? The big companies of the world aren't going to be happy that they're not selling their big exquisite thing, but it's going to also push them to, look at companies like ours to partner with, look at startups who are doing things in places where they traditionally haven't worked, and to exploit that technology. So I do think you'll see these different air forces around the world kind of take shape, built around, what is my budget that I have for a given set of capabilities, what technology is out there, who's evolving it, and then kind of who am I friends with, where can I go grab technology from as a partner nation. And so I think it'll trend kind of in a good direction. Honestly, my hope is honestly we're at this almost like new nuclear era where we look at how terrible warfare gets, and it's now not that you have to be a nuclear nation, but you just have to be a nation that has 10 million small quads with RPGs on them, and then maybe Vlad kind of thinks again about invading you. That's my hope. That was what we kind of formed around is this notion of democratized deterrence, and I think that will come to fruition.
Great, thanks. And Amir, you answered this a bit in your kind of opening, so modifying slightly. Same thing for you, and John talked about kind of the underlying tech that sort of evolved to kind of bring some of the maritime capabilities to bear more recently. Where do you see that changing for you with UGVs? What have been some of the bigger transformations, either on the machine vision side or wherever else, that's really helping get you closer to that commercial market adoption and defense adoption?
Yeah, I think to draw a theme to what everybody's saying, the higher up the autonomy stack you go, the more precise you actually have to be in the terms of the development of the technology and the customer use case. We can, develop the control system for better navigation, better perception, better operation of the actual tech. But the C2 that John was mentioning is a huge issue, and people are using that interchangeably with swarm and fleet management. And there's some big differences between it. In fact, I'm going to do another plug for John. He just put out an article about establishing a framework for essentially nuclear deterrence. I'm oversimplifying it, but the article was great. And he talks about the C2 piece of it as well, and having a framework for being able to manage when you don't have enough data on your technology, and it's hard to get that data. So in our case, let me elaborate with a scenario. So we use our autonomous ground vehicles for foreign object debris, runway checks, and all across the airfield. You'll see tools that are left behind. In fact, there was a flashlight that got into an F-35 engine this last year in 2024. It took out the whole aircraft, which cost several million. I think it was like $4 or $5 million. But imagine a screw gets lodged into a turbine of ire. It was higher? Okay, well, there you go. Well, I mean, we actually don't even see all the costs until further down because they're indirect costs that are associated with it. And the FAA will say, they have some data out there that says for every dollar of that you contribute to maintenance and operations on an airfield, that's 4 or 5 times cost savings. It's $4 to $5 essentially for any sort of damage that you have on carriers, any sort of I was talking to Fort Lauderdale airport recently, and they said they had to shut down an entire terminal just because they had damage in the pavement, and it was just basic repairs. It wasn't like they had to reconstruct the entire terminal. So whether it's an F-35 engine or it's defense, airfields or it's commercial airfields, they're very specific, small use cases that cause huge damages like this that cost millions of dollars. And when it comes back to the question of CV, we have computer vision, we have AI, ML, we have models where we have to collect data. Is this FOD or is it not? And what kind of FOD is it? Is it just garbage that somebody left? Is it a flashlight or a tool? Is it screws from an airplane? And then you can provide that information back to the airfield, the operators, and say, look, I just saw a screw or some part of an airplane that fell off on the runway. We've been able to classify that, categorize that using our computer vision models. And then that could potentially save a lot of lives and money. For the airfields. The other areas of autonomy, when we talk about command and control, especially when you have multiple AGVs, autonomous ground vehicles running on an airfield, and once you start talking about independent agents, where each robot is doing something different, they have enough intelligence where they can navigate that environment, just as a human potentially could. They could perceive it and say, okay, well, look, this is a no-go zone in the airport. I can't go there. I can draw a path and say, okay, this is the most efficient path that I can go. Once we get to a point where the robots could do it themselves, the frameworks start to break. The C2 frameworks start to break. And I work with people over at JPL, Aerial Mobility Lab, and their autonomy group as we were working on the drone stuff and the autonomous ground vehicle side. After 2 or 3 robots, it's impossible to manage it. And so we have to be able to develop out the C2 just for managing one vehicle, enable that truly software defined. It's not like remote operations, but you can actually update the capabilities of the vehicle for modularity. When I say modularity, it's can you attach different types of both software and hardware capabilities to this? Counter drones, we get that a lot, especially on both commercial and military airfields. Can you put a CUAS or a counter UAS sensor on the drone or on the ground vehicle? Can you put counter weapons of mass destruction sensors, Cyberni sensors, which are sensors essentially detect chemical, biological, radiological, nuclear, explosive, ordinances, so to speak, that could prevent, again, the deployment of troops, of first responders into these dangerous environments and prevent certain attacks. But coming back to your question, if we don't precisely go into what the technology needs to do and build out the stack and build an architecture that's scalable, and we don't precisely go into what the customer actually needs, then we actually don't develop anything. And this applies to go-to-market strategies for defense as well.
Yeah, thanks, Amir. And Grant, you kind of brought this up before, but as we've seen kind of broader proliferation of unmanned systems, hopefully for a lot of different commercial applications, we're certainly seeing that, across, government, non-DoD use cases across the United States, but also commercial industry, using them for a variety of different things. Frankly, I'm from LA originally. I actually grew up in the Pacific Palisades, and a lot of people lost homes out there. But I'm always wondering why we're not deploying firefighting assets that are unmanned. Those are very difficult conditions if you lose a small aircraft. There's a lot of future use cases for unmanned aircraft that hopefully we'll get here soon. But alongside that, knowing friend and foe, knowing where they're going, seems like the counter-UAS market has to kind of scale alongside that for us to have confidence about those aircraft operating in different use cases. So can you talk a little bit more about where you see the counter-UAS market moving in the United States? And are there big regulatory hurdles that we still need to overcome to get broader adoption. I know that's certainly been one of the things that people argue, that for the commercial drone community, that the FAA has maybe not moved as fast as we'd all like them to get adoption more broadly. But talk a little bit about where the counter UAS market is and what maybe you see changing for broader adoption.
Yeah, well, there's obviously a lot of pretty important things there, and I'll start with the end point around FAA and kind of how they think about this. So, I've over the years, as we've been involved in the counter drone space and now kind of the overall airspace management piece, we've dealt with the FAA a lot. We've been involved in a lot of their like on some of their rulemaking committees, and I will say kind of two things about the FAA. One, you'll never hear me say bad things about the people at the FAA. They are doing a very difficult job. Their mission at its core is safety, and I definitely thank them for that every time I get on a plane. But are they able to move at the speed the technology moves? I would say definitely not. You can really just point to any issue around drones that the FAA has been working very hard to work on over the last 5-6 years. There's a whole series of things that they were ordered by Congress to do in the FAA Reauthorization Act in 2018 that they still haven't done. And they've been, again, to their credit, they have been trying, they've been moving, it has made progress, but that progress is nowhere near the speed at which the technology and the distribution and availability and kind of capability of that technology moves. So that's the big challenge that they have. I think for the counter drone space in general, and I think the big shift over the last few years has been that shift from thinking about it as kind of a tactical problem to thinking about it as a larger scale sort of infrastructure problem that everyone has to be a part of. When drones are kind of only on the battlefield or only in the hobbyist flying area, you don't really have to think about it. But as soon as we start actually achieving some of these commercial things, as soon as the FAA was able to start granting waivers and licenses to do drone operations in different ways in kind of what I would think about as like the normal environment in our cities, that's when it becomes kind of everyone's problem. And one of the things that I think a lot about in the counter drone space is there's kind of a tendency to think about counter drone as, well, I think one of the things you see, and this was touched on a little bit earlier, the mention of like swarms, right? A lot of times when you're working with DoD customers, with government customers, there's a real thing about wanting to think about the next threat and, can you handle swarms? What are we going to do about these things? And I often kind of, whenever I'm asked about that, I have to kind of ask the counter question of like, okay, well, swarms, they're definitely going to be a thing. We all know that. But are you solving the problems that actually exist today? Are you solving the current threats? Or are we thinking so hard about the next threats that we're worried about that we haven't even solved the thing that are right there? And, I think we saw this in sharp relief around all the New Jersey drone sightings, right? We have mass public hysteria around drones in the air. What are they doing? Whose are they? And the reason that became such a public hysteria was because we didn't have the infrastructure, we didn't have the data to be making good decisions, to be understanding what's going on, because we hadn't put the work into doing that. We hadn't put the resources into doing that. And if everybody's always worried about the next threat, nobody's actually figuring out the current things. And so I had lots of discussions around the New Jersey drone stuff. And if you want my opinion, I mean, first off, they're UFOs. They were unidentified flying objects. So it's what can you say? Were they alien? I don't know. But the biggest thing to me is that wouldn't have gotten so out of hand if the right tools and the right information were there, so that public safety, government, staff and whatnot could actually have the data to then tell the public what the correct answer is early on before it gets out of hand. I would say there were almost certainly actually drones doing actual things in the early stages. If we're talking about the first week or so of reported drone sightings, definitely drones there. Once you get to the point where people don't think that they're, hearing the real information, then you get ridiculousness. And then we're reporting every manned aviation thing that's out there at night. And I think most people just don't spend a lot of time looking outside and seeing what happens at night, what flies around. There's a lot of stuff there. And I think that's what allowed it to get out of hand. And once things get out of hand in that way, there's no taking it back, right? So we have to be thinking about what's necessary to make sure we have that awareness. In the manned aviation in the manned aviation space, we have that, right? We have extensive networks of air traffic control, and we have ADSB, which is a huge value there with aircraft broadcasting their locations and identifiers, so that anybody can pull up flightaware.com or flight radar or whatever, and you can see pretty much the air traffic that's there. We need that same sort of thing, with aircraft, with drones. This also goes to a thing, that you mentioned earlier about kind of understanding customer needs and like what are the real problems they're trying to solve today. And one of the big, if I had kind of one piece of advice in dealing with government customers and with kind of dual use across government and commercial, it's really narrow down on what is the exact problem you're trying to solve right now, and don't try to solve the next problem. Don't try to, and when in doubt, if you're working on kind of dual use technologies, figure out what is the core piece that you can solve for all of those customers, and really focus in on solving that. And don't get distracted by, they also want to think about this kind of data and this kind of data. I think this was something that early on was a problem in the counter drone space where, government customers wanted solutions that were the perfect solution for every type of problem. And I think one of the big learnings over the last 5 years in the counter drone world is that no one solution, everybody likes to say there's no silver bullet, right? There's not going to be one solution. You're going to have different sensors, different modalities. What matters is being able to bring all of them together and be able to connect together all of the data, because that's what everybody needs. So thinking about the command and control systems, like you mentioned, how are we going to plug these things together? So you as a solution provider, you shouldn't be thinking, how am I going to solve all the problems? How am I going to provide all the data? Instead, how am I going to take my best-in-class data of the problem that I actually solve, and how am I going to plug that into these systems so that other people can use that data, so that we can fuse it with other systems, other sensors, stuff like that.
Yeah. Thanks, Grant. So I know we're getting close to time here, so let's do this as our kind of a rapid fire for each of you. But just looking ahead, more short term, next 1 to 2 years, if things work the way they want to, either for your company or kind of for the trajectory of where we're going in the department, what do you see changing? What does more adoption of these types of systems look like? And kind of describe what a realistic target might be for us 12 months, 24 months from where we are today. Amir, down. And we got 5 minutes, so we got to go rapid fire here.
All right, specifically for my company, for Airway.
You can do your company / a little bit like of the ground vehicle world.
Sure.
You can do your company.
Well, rapid fire, I think there's a lot of programs right now. Like Army has more than 20 programs on ground vehicles, and I think that's really important. We need to continue supporting that and working tightly with innovation units in order to introduce this type of technology. So for the next 1 to 2 years, that's really where the focus is going to be for us, is introducing this tech, getting it demoed, getting it fielded by both defense and commercial airfield, so we can, to Grant's point, narrow down on our requirements on the product so that we can drive this to market much broader beyond 2 years.
Yeah, I would say that data curation gets in a place that it's actually useful. Everybody's able to suck up data. Everybody's able to store data, but what are you able to do with that data? Getting that to the right place, I think, is going to be a massive enabler. And then just like my point of view is in 3 to 4 years, I hope you guys are all like 80% commercial and only 20% defense, because like we were successful in like deterring the need for like large ramp ups where like you're only doing defense. So like my hope and like my long-term goal is to like make sure you guys become commercial companies.
Like that. I'll maybe go a little bit different direction. I think open source, open protocols, standards are going to be massive for us over the next couple of years. We're building the platform, right? The aerial platform. What is built on top of that, I think, is what's actually the exciting thing. So we're building an ecosystem around the platform. We have open SDKs. We use all open protocols for communications, et cetera. And so we just really want to effectively like open the tent or broaden the tent, invite everyone in, and see what that flywheel effect of both software and hardware integrations looks like. And over the next couple of years, if it works how we're planning it, we're talking hundreds of different opportunities, capabilities, technologies built on top of the platform. I think that'll be exciting.
I think related to that openness and connecting together systems, it's the ability to share more of the data and get that awareness and coordination across all of these types of autonomous systems across both industry and government. I think that's going to be a big thing. And that level of like awareness and data sharing, that's what's going to enable all of the really good commercial uses of all of these autonomous systems. I think that's where we all need to be.
Great. Well, please, everyone, help me in thanking our panel today. Appreciate you all being here with us. I think from a DIU standpoint, we certainly think that the best technology that our country can develop is often dual use. It's amazing to see where autonomy is moving across a wide variety of verticals. Certainly, the department has a role to play in investing in certain capabilities that have kind of a core national security mission. But we think there's increasingly more overlap with the things that are being built outside of our defense ecosystem that have kind of crossover capability both for us and them. So for those of you who aren't working in the department or working with Department of Defense, certainly hope that you pay attention a little bit more to what DIU is doing and some of the organizations that we work with, because we're really trying to sort of change the ability for our warfighter and our capability to get integrated faster. So with that, please help me in thanking our panelists today. Really appreciate the conversation, and I hope that the visions that you're all talking about become reality here. So thanks so much.